Measures to mitigate urban heat island in Indian cities with blue-green assets. It is estimated that by the end of the 21st century, climate change will result in a 1.5 degree increase in global temperatures. In India, the temperature is expected to increase by 2.7 degrees Celsius at the most optimum rate of emissions and by 4.4 degrees Celsius under the worst-case scenario. This shall put several cities in the Indian subcontinent at an unprecedented risk with an increased frequency of climate change-induced natural disasters such as urban flooding, drought, and heat waves, amongst others. India is also listed amongst the high-risk countries in the World Risk Index of 2016 facing threat due to climate change. Urban heat island may double this temperature increase, making communities more vulnerable. The additional increase can be attributed to the higher rate of carbon emissions from transport and energy sector. Also, buildings and blacktop surfaces contribute further to this rise in temperature. On the other hand, green cover, water bodies and natural landscapes help in reducing heat gain. There are 4 primary objectives of this use case, including providing evidence-based actions and interventions to minimize UHI and proposing fit-for-purpose solutions. The use case shall help various local bodies and agencies to identify the priority areas for planning their actions towards rising urban heat and associated challenges. The use case also helps to quantify the impact of land use planning on urban heat. The city of Jaipur has been used here to demonstrate this use case. At the outset, spatial data sets and information about the city's current and future development patterns needs to be collected, including existing land use map, proposed development plan, road network, topography, water bodies, population density, soil typology, and thermal image of the city boundary. For the heat map, 30 meters resolution data is available from Landsat, which is insufficient to identify the surfaces which directly affect urban heat. However, for accurate mapping and zone identification, drone mapping comes in handy. The land surface temperature map is processed to arrive at the urban heat island map using remote sensing software. An overlay analysis is then conducted to ascertain the relationship between UHI and land use and to identify hotspots within the city and affected city population. After identification of heat zones within the city, the urban heat islands are categorized for spatial clustering and their location and context. On comparing the UHI map for a residential neighborhood with a mean temperature of 37 degrees as base to that of an industrial area, it is clearly visible that the industrial zones are significantly hotter compared to the residential zones. To understand the impact in a granular manner, let's zoom in on both of these land uses. The VKI industrial area experiences temperatures higher by more than 3 degrees Celsius in some locations and at an average elevated by 1.11 degrees Celsius. Another example is of the industrial area of Chhotwada, which shows temperatures higher by a mean of 0.76 degrees Celsius. Moving to Chhotwada residential area, which is an organically developed mid-rise residential area with a green cover or tree canopy of 1.22%, and it experiences temperatures higher by 0.29 degrees than the city's average. While Mansarovar, a neighborhood planned and developed by the State Housing Board, has 9% of area allocated to parks and green spaces and a canopy cover of over 7.5%, which has temperatures cooler by 1.2 degrees compared to the rest of the city. Globally, many cities have used blue-green assets effectively to mitigate the impact of urban heat islands and improve their microclimate. One such example is the city of Medellin in Colombia, which realized the interlinkages between climate change and growing urban heat islands in 2017. The city then developed citywide green corridors by planting over 8,000 trees and 3.5 lakh shrubs. It also used an area beneath a raised metro line to collect rainwater to help water the green belts. Temperatures have come down in these areas and their surrounds by as much as 3 degrees Celsius. It has also helped the urban biodiversity in terms of its flora and fauna. Thus, Once a city possesses such a tool which enables it to assess the cooling potential of its blue-green assets, it will pave the way for ideating modifications and enhancements to its urban landscape to maximize the cooling benefits and move towards a climate-resilient future. For more information, please contact UN Habitat India. Thank you.